Alright guys, look, we've already established that some funky stuff can happen when you combine alpha particles with atoms and neutrons with atoms, smash them together at a high rate of speed. You can get lots of different stuff happening. The question is, once you get that crazy stuff happening, the products of the reaction, are they stable or are they not? Let me tell you, there's a way to predict it. It's called the belt of stability. And it's you plotting the number of protons and the number of neutrons that are in the atom on a graph. You know, higher protons on this side, more neutrons this way. So our lightest elements, like lithium, are down here at the bottom, and our heavier elements, like mercury, are kind of towards the top. Now, here's the deal. If the number of, or the ratio of protons to neutrons lies along this blue line, it's actually probably pretty stable. For some reason, atoms that have this particular ratio of protons to neutrons in these amounts happens to be pretty stable. For light elements, it happens to be about 1 to 1, but that breaks down for the heavier elements, so don't worry. That's this black line that I've drawn. It's the 1 to 1 line. Just don't worry about it. It's a line over here, but not over here. No one else cares. Here's the deal, though. If you create an atom in one of these crazy nuclear reactions that lies, for example, here, that's not in the belt of stability. It's way too high for where it should be for this number of protons. Let's say this is, I don't know, 50 protons, like this tin. But this has way too many neutrons. It has like 120 neutrons, and but it only needs 70. What's going to happen? How are you going to move back to the belt of stability and get rid of some of the neutrons which you have too many of? Well, the answer is you're going to get rid of them by ejecting neutrons, or, as we like to call it, beta radiation, because the number of protons goes up when a neutron disintegrates into a proton. So not only would you increase the number of protons, but you could also decrease the number of neutrons. And that's what happens to elements that lie in this area on this diagram. But let's do another example. What if your element laid here? Well, for this number of protons, you need more neutrons. Or you could just get rid of some protons. In this area, we have too many protons. How can we get rid of protons? Well, there's another kind of emission for that. It's called positron emission. The proton breaks up, gives you a neutron. That's what happens to stuff that lies in this area. I got news for you, too. If any element has more than, I think it's 84 protons, it ain't stable no matter how many neutrons it has. That's why I've drawn this little barrier here. This here is 84 protons. See how it lies in the high region of the number of protons there. More than 84 protons, it has too much everything. Too many neutrons, too many protons. You got to get back to this area where you can even consider the belt of stability. How can you get rid of protons and neutrons? The answer is alpha radiation. You get rid of 2 protons and 2 neutrons at a time with alpha radiation. So we can predict what kind of radiation it gives off if we know how many protons and neutrons it has. Because if it lies here, there's too many neutrons, and we got to do beta radiation. If it lies here, there's too many protons, we got to do positron emission. If it lies up here, there's too much protons and neutrons. That's alpha particle emission. And don't forget, the only other kind of radiation you can have is gamma radiation. And it can basically happen for any of these. It just happens when you have too much excess energy and you got to throw it off somehow. Point is, you can predict how to make a nucleus stable and what kind of radiation it's going to make based on the number of protons and neutrons. Belt of stability, look it up. Best of luck.